Hello guys, and what's up? So how are you guys? Hopefully you guys are doing fine, and today, as you can see, this is the progression question, additional math, and this will be my first video regarding a progression topic. Diagram 2 shows part of the arrangement of 509 tiles on a wall of a room. So fine, so this is the diagram, as you can see, and fine. Okay, question A, the number of rows of the tiles that can be arranged. Okay, so basically we're gonna find the number of rows. So basically this is the first row. I mean, this is the 1 row, 2 row, 3, 4, 5, and next, and including this also, but this is must be the double of this part, right? So this is my way. So one way is maybe I could find the row, this part first, then I can multiply by 2 and then add this one. So let's see the pattern. So yeah, so I consider this part that I highlighted here. Okay, so let's consider the progression. 4, 5, 6, 7, 8. So 8. So I could go until certain value. So this as you can see, the pattern here forms a geometric progression. Why? Because it has a common ratio. It has a common ratio of 4 divided by 2 and divided by 4, which is 2. So it has a consistent ratio, which we can conclude this could be the geometric progression. This is our very useful information. So the total number of tiles is 509. Total 509. But this includes the first part there and the second part plus the tiles in the middle. So what we do, I want to find the first part from the one that I boxed there, which is equivalent to 509. So part 1, how many tiles from part 1 from the first region that I boxed there is 509 minus 1. You minus the middle, okay, left you with the first part and the second part. So I want to find the only first part, so I divide by 2 and I get 254. Okay, 254. So this is the part 1. So then we use the geometric sum. So sum of geometric progression is equivalent to the first term times with common ratio to the power of n minus 1 r minus 1. This is equivalent to 254, isn't it? Okay, so let's continue. So we know the sum of the geometric progression is s. So the first term there is 2. Okay, clearly it's 2. So this is the first term a. So 2 times with the r with the common ratio we have highlighted before, which is 2 also. And n is number of terms, or simply how many rows this first region or the first part there has. Okay, so 2 to the power of n minus 1 divided by r minus 1, which is 2 minus 1, which is 1, equivalent to 254. So we just rearrange, we get 2 to the power of n minus 1 equivalent to 254 divided by 2, 127. Okay, 127. And then we eliminate the 1, so plus 1 both sides. We will get 2 to the power of n equals to 128. And then we log both sides, log n equals to, so this n move in front. Okay, move in front using the logarithm law. You must remember that, basic. So log 128 divided by log 2 is simply 7. Or if you're familiar with the exponent, you will just directly come forward with the value of n equals to 7 if you are familiar with the exponent. So this has 7 rows. Okay, so this is 1 rows, and this second region or second part must have 7 region too. 7 rows. So we have 7 row plus 7 row plus 1 row is 15 rows. So this is 15 rows all together. So let's go into the next question. So question B, the number of tiles in the bottom row. So as we has discussed just now, the number of rows there is 7 rows, and it has a total of 254 tiles. Okay, 254 tiles. So it forms a geometric progression which is 2, 4, 8, and have a common ratio of r equals to 2. So it has 7 rows, and the bottom one or the bottom rows is the 7th row. Okay, so we are going to find, so in here we know that n equals to 7 because n is the number of terms in geometric progression, but here it represents the row of the tile. Okay, so we are using the Tn formula in geometric progression. So Tn equivalent to ar n minus 1. Is it? Okay, let me explain a bit. So this is T1 or simply A, but let me use T1. So this is T2, T3. And we want to find what is T7. So T1 here represents 2. So when n equals to 1, or when the first term, meaning the value of T1 is 2. Okay, when n equals to 2, the value of T2 is 4. Okay, so this is T1, T2 is just term. Okay, term in the geometry in the progression. Okay, so we are going to find T7 equivalent to A, which is T1 or 2. So R, which is also 2. N minus 1, which is 7 minus 1. We know n equals to 7, so 7 minus 1 is 6. So 2 to the power of 6. So when we multiply, we're just using the exponent law. 2 to the power of 7, which is 1 to 8 tiles. We just worked on this previously. Okay, so if you cannot do the exponent law, actually you must have to. Okay, you must master all kind of theorem or identity in math, especially the law of exponent and also the logarithm law and all kind of law lah. You must remember, not remember, actually you must understand them. So using calculator 2 to the power of 6. You just press the calculator if you are too lazy to find or to think. So it is 1 to 8 times. And I think we are done. So guys, that's all from me regarding the progression question. But then I think in future I will upload more about this topic because it is interesting, of course, and I love this topic so much. If you guys have any question to ask, feel free to ask me on WhatsApp and whatever social media I have. And thank you.